Welcome to day 6. Today we are solving 122 best time to buy and sell stock. Okay, let's get started. You are given an integer array prices, where prices I is the price of a given stock on the ith day. On each day, you may decide to buy or sell the stock. You can only hold at most one share of the stock at any time. However, you can buy it then immediately sell it on the same day. Find and return the maximum profit you can achieve. So we have the first example where it is 7. Okay, let's see how it's 7. We buy on day 2 when price is 1 and sell on day 3 when price is 5. And then we buy on day 4 and sell on day 5 when profit is when price is 6, so that overall the sum of our profit will be 7. Okay, so the next we have 4 as an output. Okay, how do we do it? We buy on day 1 and sell on day 5, which will give us profit of 4. Okay, this also works. Okay, next we have this decreasing order. No matter when we buy, we always end up with 0. Okay, that's clear. What constraints do we have? Prices can have one or more items. Okay. Next, let's think about the question. We can buy and sell. We should find the biggest profit we can make. I'm thinking about this case. One thing I noticed is can I get the same profit if I buy and sell whenever there is any profit? Will it make sense? I'm talking about I buy at day 1, I sell at day 2, because it gives me profit anyway, so I get one profit. Let me write it like this. Then I buy at day 3. Another question is can I buy again on day 2? At most one share of a stock at any time. You can buy it then, immediately sell it on the same day. Okay, seems like I can buy on day 2 after I sell it. I wanna buy on day 2 again and sell on day 3. That gives me one profit. And I wanna buy on day 3 and 4. That gives me another one profit. And I wanna buy immediately at 4 and 5. That gives me another one, which will be 4 and in sum, and that matches the overall price, that matches buying one at day 1 and selling at day 5. But this one is much better, I believe, because this approach can be used for any solution. You can just try to buy and sell on every day, but there are some conditions for it. Let's think about it. We have this case now. It matches our first, so we can just buy and sell when there is a profit and buy again. That makes sense. But here, let's say we buy at 7 and try to sell at 1. That gives us a negative, which means we should not buy at 7, and we should actually buy at 1. We should skip this one. Okay, if negative, skip. Let's imagine we didn't buy at day 7, we say. And then we try to buy at 1 and sell on the second day, next day. Well, we have a profit of 4. We don't skip it. And the next time we imagine we buy at 5 and sold at 3. It's negative. Let's just say negative. So let's imagine we didn't buy at that day. We say buy at 3 and then sell at 6. Siri is thinking I didn't call Siri. Okay. This time we have a profit. We keep it. And we buy at 6 and sell at 4. This is negative. We just want to skip. We just want to imagine this never happened. That makes sense. It also works for the another case, like for this case, where we have it's like every day we try to buy and it's negative and we skip, and we try to buy at 6 and 4 negative, we skip. It's something like that until the end. We end up with 0 count of the sum. Okay, I feel like this strategy works. Do we have any other edge cases where it may not work? Okay, let's think. Okay. Do we have any constraints? Okay. If we have one element, we just buy and see we don't have anything to sell. Okay. What we can do in this case, I feel like this logic works. You can try to code it on yourself, but before, let's talk about time and space complexities. The first thing, time complexity. You can pause the video right here and think about it, and I will go and tell. The time complexity for this one is big O of n, because we are going through every element. And yeah, and the space is O of 1, meaning that n is the length of array. O of 1 constant because we are just going through the list that's given to us. We are not duplicating it, not splicing, adding, or anything. Okay, so we are just keeping a score where we have the sum. We are calculating the sum and the current, but that gives us that's constant. So we have a constant space and linear time. We don't have any follow-ups on this question. Okay, so I will start coding. You can again pause the video right here, try it yourself, then compare with my code. I like to write pseudocodes, as you know. Loop. If current bigger than previous. Okay. Before loop, I can say initialize sum. If current is bigger than previous, add to sum. Add difference to sum. Else, skip. Yep, we are not doing anything, we are skipping. If they are equal, we want to skip because that's just 0 profit, which doesn't change our sum even if we add it. Okay, let's loop. I will loop with indexes, so I just want to get previous with index. I will start with 1. I equals to 1. I is less than prices dot length. I plus plus. Let's initialize our sum. Let sum is 0 at the start. Moving on. We have this condition inside our loop. Tab, and another tab. current, which is prices I, previous, which is prices I minus 1. It will be 0 and the 1, and in the first iteration I'm starting at I here, so previous will be this one. Yeah, I think it's clear. Next, I check it's bigger, then I just add to the sum. Okay, sum plus equals the same with minus. I just wanna do the subtraction and add it to the sum. Else skip, we don't have to do anything. We just return sum. Okay, let's just try run our solution with given examples. The first one, it should actually work as expected. Let's see if there are any errors. Okay, and let's initialize I starts at 0, prices previous. Here we are checking ups starts at 1. Here we are checking 7 and 1. Is 7 bigger than, oh, actually we are checking 1 and 7. Prices I is 1, prices I minus 1, previous one is 7, so it's not bigger, we skip. Then next iteration we have 2, and this time we are checking 5 and 1. 5 is bigger, we add 4 to sum. Our sum becomes 4 at this stage. Okay, and next we have index 3. We are checking 3 and 5. 3 and 5. We have difference of 2. We add it. Actually, I'm confused again. Like 5 and 3 in this order. Sorry. It's 3 and 5. 3 is not bigger. We check, is 3 bigger? No, we skip. Then we have 6 and 3. Is 6 bigger? Yes. And what is the difference? 3 added to the sum becomes 7. Then we have 4 and 6. 4 is less, do not add it. So our sum is now 7, we return the sum. Seems like it's working as expected. Let's remove the notes, and no, let's not remove them until we get we submit it correctly. Okay, test case is accepted. Okay, so our solution passed, and now I can come here and refactor my code so it looks beautiful. It indeed looks beautiful right now. Let's just keep the code here. I can just submit again. Okay, it's working, and now it's time to go to the solutions. Okay, invert traverse from backwards, travel from backward. Okay, updating max and minimum elements. Let's see the code. Actually, it's I didn't get it. Maybe I'm a beginner. Let's see, beginner friendly. Beginner friendly is my answer, so I'm a beginner, yeah. Let's go. Okay, another thing I like to do. Let's take the second approach. Who is doing better than us? How? Let's see, memory. Who is this? That's doing the same, but their memory is less. So unfair. What about runtime? The same. J and I. Wow. Okay. The same. Okay, do we have any other solutions? Maybe at least like I can check JavaScript and maybe there is a better syntax than my code. If you are solving in Python, go check Python and see if they are using like better coding syntax. The same, but the J is like they are, instead of me, I'm telling I minus 1, they are keeping J. Okay. I believe we can end the video right here since most of the solutions are the same. We have checked all of them. Not all of them, like at least 3, as I said we checked. Thanks for watching, subscribe, and have a nice day. Bye!